Hello Geometry, and welcome to 9.2 Special Right Triangles. This is an especially important section because it will stay with you in every math class where you have to do any sort of trigonometry. You've noticed that with Pythagorean theorem, the three sides of a right triangle are related in a very specific way. Well, we're going to look at two triangles where the angles of the triangle in a right triangle also determine some very special relationships among the sides. This is going to be kind of a long video, so you might want to break up the first page, take a break, then continue with the second page. On this page, we're going to look at 45 right triangles. So 45 degrees is what we're talking about, which, because these two angles are the same, that does make it an isosceles triangle. So what I'm going to do is I'm going to make each side equal 1. So those are the legs. And then using Pythagorean theorem, we want to come up with the length of the hypotenuse. And the reason why I'm going through sort of this derivation of the three relationships, or the relationship of the three sides, is so if you forget the ratios, you can derive it yourself. So all I've done is call each of the two equal sides 1. Then by Pythagorean theorem, 1 squared plus 1 squared, well, that's 1 plus 1, which is 2. And we know then we take the square root, so this side will be the square root of 2. That relationship is always going to hold. And we know with similar triangles and dilations that if you multiply each side by the same scale factor, we're going to use a scale factor of x, then that keeps the same ratio of the sides. So I have my 45 angle here, angles, and then I'm going to multiply each side by x. So this becomes x rad 2. And that is the relationship. So if the side length was 3, it would be 3 rad 2. Think of the conga line. 4 rad 2. 5 rad 2. That is the basic relationship in a 90 triangle. X rad 2. Now, that relationship can be manipulated. So let's look at a few examples. We're going to start with the easier examples. So again, it's 45, so I know that these two sides are the same. So x over here is going to be 5 rad 2. Over here again, now I sometimes like to, depending on the difficulty of the problem, I will sometimes write those ratios on the inside of the triangle so that I can make a relationship. So I know that x is 11, so down here I have 11. Over here, I know this will be 11 rad 2. And don't forget, you can always use Pythagorean theorem. If you know two sides, you can find the third side. Well, over here, now let's write those ratios on the inside. X rad 2. So I notice here that x rad 2 equals 23 rad 2. That must mean that x is 23. So you can sometimes solve for the unknown by letting the side equal its ratio. So we have x rad 2. So I know this side will be 4 rad 5, and that third side is going to be 4 rad 5 times rad 2, and this together becomes 4 rad 10. So that would be your hypotenuse. Okay. Now let's do a few harder problems. So let's start off with rad 6. Oy. So we have x rad 2. There's several ways I can go about this problem, but I'm going to show you a little trick. I know that square root of 6 is square root of 3 times square root of 2, which then makes the square root of 3 my x. So this will just be rad 3, and this will be rad 3. So sometimes if you can break it up like that, you can solve. Now here comes one of the harder ones, because this is always going to require rationalizing a denominator. We know these two sides are the same. It's a 45, 45. Now let's put those ratios on the inside. This was x, this is x, this is x rad 2. So what we're going to do is we're going to let x rad 2 equal 12. And our goal is to solve for x. So I'm going to divide both sides by rad 2. Well, that's nice, except you can't have a radical in the denominator. So we have to rationalize. How do you rationalize? You take what that radical is and we multiply by 1, because that doesn't change anything. It's kind of just converting it to a new format. So on the bottom, this becomes 2. So far I have 12 rad 2 over 2. And since I can simplify that, those will cancel. You can't ever go inside the radical, okay? If you're not in the rad club, if you're not under a radical, you can't talk to any numbers under a radical. But I can simplify outside, so x becomes 6 rad 2. So down here we have 6 rad 2 and 6 rad 2. Now a little shortcut for those of you who kind of remember the patterns. Because I had to rationalize with rad 2, notice you're always, when you have an integer on the side with the radical, you're always going to take half of that number times rad 2. Always going to be half that number times rad 2. Now look at this lovely number here, 9. Well, what I just said still applies, but you know what? Let's work it out. So this was x, x, x rad 2. We're looking to see what is x. So we have x rad 2 equals 9. We know we have to divide by rad 2. We know we have to rationalize. And although this cannot be simplified, I can then just write it. So like I said, it's always going to be half. So there's half of 9 times rad 2. So this is 9 halves rad 2. All right, so when an integer is on the side with a radical, it's always going to be half that number, whether you can simplify or not, times rad 2. All right, let's try a word problem. The length of the diagonal of a square, well, we know that a square has 4 sides and 4 right angles, and we have a diagonal here, and it tells us, so that also means these are 45, 45, because it bisects those right angles. The diagonal is 32, and they want us to find the perimeter. Well, we can use that little trick we just did. So we have an integer, whoops, sorry about that. We have an integer on the side that would be the rad 2 side, remember, because this is x, x, x rad 2. So if I take half of that, half of 32 is 16 rad 2, and that would go the same for all 4 sides. Since in a square they're all the same. So I have 4 times 16 rad 2 is going to equal my perimeter, which is going to be 64 rad 2. Now, if I took a liberty with finding that 16 rad 2, let me go back and show again. This is x rad 2 equals 32. You would divide both sides by rad 2. To isolate x, then you have to rationalize. So notice when you rationalize, it's always like dividing by 2, and half of 32 is 16. All right? Might want to take a little break, and then we're going to look at some 30, 60, 90. All right, geometry. So here is the 30, 60, 90 right triangle, well, 30, 60 right triangles. So what I want to do is, again, go through the derivation so that you have a good idea of, if you forget the ratios, how you could derive it for yourself. So we start with an equilateral triangle because we know all the angles are going to be congruent, 60 degrees, all the sides are congruent, and I'm going to make each side worth 2. You could do anything, but 2 is a nice friendly number, as you'll see in a second, because we're going to cut that triangle in half. And when I cut it in half, so this is still 2, the base now here is 1. This bottom angle is still 60, but the top angle gets cut in half as 30 because we just drew a line right down the middle of that triangle. And we can use Pythagorean theorem to figure out what the opposite side would be. So I have 1 squared plus, let's call this side b for no other reason, b squared equals 2 squared. And so we want to solve for b squared. So I get that b squared is going to equal 4 minus 1, which is 3, and then we take the square root. So this side is going to equal square root of 3. All right, so those are going to be the ratios for any 30, 60, 90 right triangle. So this is 60, this is 30. So opposite the 30, I can call that x, 1 times x. The side opposite the 60 is whatever the 30 side is times rad 3, and opposite the 90 is 2x. Notice that it goes in progression from smallest to largest because the opposite angle is related to the opposite side. So this is the 1, this is the rad 3, this is the 2, or x, x rad 3, 2x. All right, so those are the ratios that go on the sides opposite those particular angles. The 30 is the smallest angle, it is going to be the smallest side. And so then you can see that repeated here in our theorem about 30, 60, 90 right triangles. So let's solve a couple problems. Again, what I like to do is write the ratios on the inside. So here's my 30-degree angle. Opposite is going to be x. The hypotenuse is always going to be 2x. Opposite the 60 is x rad 3. So I know, based on what I'm given, that 2x equals 14, which tells me that x is going to be 7. So opposite the 30 is 7, and opposite the 60 is whatever the x is, which is 7, times rad 3. Okay, hopefully that was okay. Let's do another one. So opposite my 30 is, I always call it x. I know sometimes you can use a different variable if there are x and y's for what you're trying to solve. Hypotenuse is always 2x. Opposite the 60 is going to be x rad 3. All right, so let's see, what are we given? We're given 2x equals rad 6. So I'm going to show you a little trick here. No, I'm not going to show you a trick because that wouldn't work with this. Never mind. Let's go ahead and do this. So I know that 2x equals rad 6. I'm trying to solve for x so I can then fill in my x's everywhere. So I have to divide by 2. So this side is going to be rad 6 divided by 2. The 2 is outside a radical, so it does not talk to the rad 6. You have to be in the rad club to talk to other radicals. All right? So that's not the equivalent of rad 3, so be careful with that. And then if I double that, though, then what we have is rad 6 divided by 2 times rad 3. Now this is kind of looking a little messy, so I'm going to do this down here. What you're going to want to do is simplify that, because on top I have rad 18 divided by 2, and this can be simplified because that's rad 9 times rad 2 over 2. Rad 9 is 3. So this will all simplify to 3 rad 2 over 2. And that is what should be on that side. Sorry about that, it's kind of a mess. Okay, now for this next one, putting our ratios on the inside, x rad 3, 2x, you can notice that x rad 3 and 5 rad 3 are on the same side. So that must mean that x is 5, so my hypotenuse is 2 times 5, which is 10. All right, and now we have our 30, 60, 90. So again, this side will be x, this is going to be x rad 3, this side will be 2x. So what I want to do is figure out what is x. That's usually going to be your goal. So I know that x rad 3 has to equal 12. So I divide both sides by rad 3. And then we have to rationalize because you cannot have a radical in your denominator. So we multiply top and bottom by 1. This turns this into 3. And so I have 12 rad 3 divided by 3. And that will simplify to 4 rad 3. So that's my x value, 4 rad 3. And now I can double that. Again, you only double the number outside the radical. 2 times 4 is 8, and the rad 3 just gets carried along. Okay, in this last problem, we have a 30, 60, 90 attached to a 45, 45. Remember, these two sides will be the same. So you have x, x, x rad 2. We're going to work on the 45, 45 first. So I know that x is 5, so I know this side will be 5, which means y will be 5 rad 2. Now when we move over to the 30, 60, 90, this is the x side. This is x rad 3. And again, the hypotenuse is 2x. So this is going to be a little more difficult because I now have that 5 equals x rad 3, and we have to rationalize. So divide by rad 3, and then multiply top and bottom by 1. So we have 5 rad 3 over 3. So that's going to be your W. Oops, sorry about that. That was the x. That was the x value. Got ahead of myself there. The x value, which we're calling z, is 5 rad 3 over 3. And if I double that, you're just going to multiply the top by 2. And that gives you 10 rad 3 over 3 for W. Okay, now we have the bottom. So this is an application. We've got a dump truck, and it's raised to empty a load of sand. How high is the 14-foot long body? So that's along here. How high is it? So that's what we're trying to find when it's tipped upward at a 60-degree angle. So I'm going to redraw the triangle out here just to kind of take it out of the picture, although I drew it in the opposite orientation, but that's okay. So that was 40, this is 60, this is what we're trying to find. I'm actually not going to call that x because that gets confusing. This is the height, so let's call that h. If I put my ratios on the inside, so 30 is here, this is x, this is 2x, this is x rad 3. So I know that 2x equals 14, which tells me x is 7. So my height is going to be 7 rad 3 feet. And that would be the answer. All right, I hope that helps.